All right, back again, guys. So what we're gonna do today is go through some of the key modules, namely, like I think the core three for me for data science basics would be like NumPy, Pandas, and PyPlot or Matplotlib. So we're gonna go through and show you what you can do with some of the basic modules and kind of get you up to speed really quickly. All right, so let's get started. Okay, so navigate back to your terminal. Okay. So let's spin up our second notebook, okay? Or let's actually, I'm back in my home directory. I'm gonna just make a folder called data, maybe even data science. I'm going to cd into data science, and maybe it's a good practice to just kind of to collect and keep all of your data science products in one place. I do that with I have a development folder. I keep all my stuff over there, so let's make it a data science folder and let's just start doing all of our data science projects there. Okay, cool. So let's spin up our second Jupyter notebook. So if I type that, cool. So this directory is empty. So it's spun up. This is like the root kind of the Jupyter notebook. If there were files there, it would show us. But we can create some files. So let's start a new Python 3 Jupyter notebook. Great. So let's call this one data science basics. Very, very, very basics. So we're going to start really, really slow. Okay. So if you're doing this course, you probably have some basic familiar with Python. So what you can do is import modules, right? So remember we talked about Anaconda. Anaconda, basically, when we downloaded about like 30 to 40 modules that are already ready for us to use that we don't have to go and download. And if you hadn't done that and you wanted to use a module, you would have to go and install it right now and then kind of import it. But for now, Anaconda has already made all of these things readily available. Okay, so the three ones we're going to look at today are called NumPy, so that's one. And it's typical for NumPy, you give it a little nickname, call it NP, because you use it all the time. The next one we're going to look at is called Pandas. It's a funny name. And this one also has an alias. We're going to call that one PD. And finally, the last one we're going to look at is called Matplotlib. And within Matplotlib, there is a module called PyPlot. This is just, if you look anywhere, Stack Overflow, these are what everybody has, and we're going to call this one PLT. These are all typical. Now I'm going to run this cell. Okay, so Control Enter. It's going to take a second, but all of them worked. Great, fantastic. Okay, so we've imported all the key modules, and now we can start to play with them. One thing that I want to do though is I want to show you one other Jupyter trick that I missed out on in the last video, which is basically incorporating Markdown into your notebook so you can get some added kind of organization. Okay, so a cell, so I added a cell above. This was, remember, escape A. A cell has a type associated with it. So right now, these cells are code cells, right? So if I type in here, it's going to assume it's code. I can change the type right here. So I'm going to call this cell Markdown. Alternatively, I could have used escape M. I believe escape M will change it. So right, I just changed this cell to Markdown. So if I execute it, control return, it thinks it's actually Markdown. But I don't want to do that. Let's change it back to code because that scares me. All right, let's execute it again. Okay, perfect. Now, once it's Markdown, I can do things like add headers. So it's very typical that I would just kind of put like, okay, here are my imports, and I'm going to just keep all my imports in the same place. And again, you still got to execute it. So that's Markdown syntax, right? You use the hashes to get different size headings. If you want to see more about Markdown syntax, I recommend you use it. Markdown. It's actually put out by GitHub, I believe. There's cheat sheets all over the place, but I'd recommend. So here's this header stuff, emphasis. So you can use all of this stuff in your IPython notebook. So that's really helpful for getting things organized. So we're going to use that as well. So I'm going to say, let's call this section numpy, and I'm going to change it to Markdown using escape M, and then I'm going to evaluate it. Okay, and then I'm going to add a cell below, escape B. Cool. Now let's play with some NumPy. All right, so what is NumPy? NumPy is a basic building block for a lot of what goes on in numerical computing, right? So Python is fantastic for numerical computing, but it doesn't necessarily make things very some things aren't very easy off the shelf. In particular, what I think of NumPy as is like it helps me get like vectorized operations. So if you guys have any like backgrounds in like linear algebra or things like that, where you're playing with matrices and doing things in that direction, NumPy is what is going to give you lots of that, or NumPy is one of the things that's going to give you lots of that functionality. So just as a kind of an example, let's set up two basic Python lists, right? I'm going to set up these two lists, and I just want to demonstrate where vectorized operations starts to come in. Okay, so I just added these two arrays to x and y. They're both numbers. One thing that's very common that you would want to do in math is just to like add arrays together, right? But Python has its own understanding of like that additive operation for lists, right? It does the same thing for strings. It's not doing what I really intend it to do is to add the arrays and element. It's called element by element. So this is like a vectorized operation, but it doesn't do what I want. So instead of that, what I'm going to do is I'm going to introduce a little bit of NumPy syntax. I'm going to call these a NumPy array. This is a NumPy array. So I'm going to, instead of a typical list, I'm going to change them to NumPy arrays. So now let's look at one. So it's basically a Python list, but they have this array wrapper around it, right? So that's going to allow us to do a bunch of the stuff that we would expect it to do, right? So if I was adding two arrays in math, this is what we would expect to happen. So this is what you call, again, I'm going to repeat it, vectorized operations, right? So if I wanted to achieve this using basic Python, I would have to do some type of like a list operation, right? Which would just be annoying if we had to do them all over the place. So it enables me to do, I can square them, right? So I just, I wrapped it that, an array plus an array is just another array, and then I can do a vectorized exponentiating operation over it. So this is a lot of, let's call this Z. So this is really where NumPy starts to be super, super helpful. So obviously these are just some simple operations, but this is kind of the core of what NumPy is starting to enable. Now, when you think of a matrix, right? So an array is basically the building block that enables us to get to matrices, right? So an array itself is just an array of numbers or strings or whatever. Now a matrix is effectively just an array of arrays, right? So if you think of like the row column kind of 2D matrix that we're used to seeing, is just an array of arrays. Actually, and not to just to kind of wet your guys' whistle, so beyond 2D, there's like higher dimensional matrices too, right? Those are called tensors. So when you think of like a 3-dimensional matrix, it's like a cube. It's not just a flat matrix, right? It's a cube. That's an array of an arrays of arrays, right? So that's called a 3D tensor, or And it goes higher dimensional than that. So if you looked up cool packages that Google just released called TensorFlow, that's what they're talking about. So a lot of what they use in things like deep learning, they actually have these really large tensors full of data that are flowing, have these flowing through these graphs of they call it computational graphs, whatever. But I just kind of like want to wet your whistle of what's possible here. So let's just create our first matrix with NumPy. So let's create an array, np dot array of x comma y comma z. Oops, I actually wanted to do this. So here now we have the matrix that we were thinking of. Here's our x vector, here's our y vector, and here's our z vector. So if this was a matrix, we'd have row and we'd have column. Okay, so without just so we don't dive too deep into NumPy just now, we'll learn more about it as we go along. But I want to introduce pandas as well. Okay, pandas. So we want to change this into Markdown. Now we're going to get a little pandas section. Now, I'm going to call this array of array. Let's call this matrix. I'm going to call it map for matrix. Now, pandas is, if anybody has done any R, there's a concept in R called a data frame. Okay, this is the fundamental concept in statistics, or just in statistical computing. A data frame is like, it's basically a matrix, but a matrix with like lots of special properties. So there's like lots of operations you want to do on matrices all the time, concatenating matrices, adding, deleting columns, all these types of things, apply functions. And so in pandas is basically when a lot of the Python community, I guess, yeah, maybe it's a moment just to do some history here. So R was like one of the first big statistical computing packages that really killed it in the open source world. Everyone loved R. But if you were using R, it was really hard. So it was great for statistics, but it made it really challenging to incorporate that with the rest of your your programming stack. So maybe you wanted to scrape some data, right? Scraping data, like maybe you can do that in R today, but that's a crazy concept. That R is not made for that. So what that meant was data scientists had to use one language to scrape data, another language to spin up an application, another language to do the statistical computing, and then it was a nightmare trying to tie everything together. So part of the Python, I think in the early, like kind of mid 2000s, someone in the Python community, I forget his name at this moment, but they basically rebuilt out and ported the R data frame concept into Python. That became what is known as pandas. All right, so let's create our first data frame, and we'll look at some of the magic of it. And it's really easy to create data frames. You can do it in a number of ways. It's typical to, let's do it actually. Let's just do PD. So that's our pandas library right there. And I'm going to say data frame. Okay, now let's put in our NumPy matrix. Boom. Now we have a pretty little data frame, right? So a couple other things to take note of here are just it'll help you down the road just from a conceptual standpoint. When pandas came to be, pandas actually uses, well, for one, it's really highly optimized. So if you wanted to build anything like pandas, you're probably not going to do as good of a job as they'd have, because it's optimized using like a bunch of like lower level C and things like that, so it's super quick. But in particular, what they use is a basic building block is NumPy. So a data frame is so here we have a data frame, right? So a column or a row is what's known as a series, okay? And which is another pandas type object. It's basically like a one-dimensional data frame. And but at the core of a series it's basically just a NumPy array. So NumPy and Pandas play very nice together. You can go back and forth between them. I think I can just say like 2 matrix or something. I think, is it just 2 maybe 2 matrix? Matrix. Forgetting at the moment. Maybe it's like this. Pandas. I'm just going to look it up right now. This is good for you guys to see as well. Pandas data frame 2. So I think it's called 2 matrix. Yeah, right there. As matrix. Right? So this was our original matrix. So if I type as matrix, it just goes back to the NumPy equivalent of the data frame. Okay? So there's the basics of our data frame. Typical convention is to save out your data frames as df, right? So let's save that data frame. Now let's look at what we might be able to do with this. Okay, so one thing you're going to want to do is say do some simple things like, so there's a head operation. This is a very small data frame, so can't really see. What head does is it prints the first 5 rows of a data frame, or I can control, let's say, the first 2. So a lot of times when you want to summarize or you want to look at what the data in a data frame kind of is, but you don't want to print out the whole thing at once because it might be really big, you use things like head. I can also use tail. Tail prints out the bottom too, okay? So if or 2 or 5 or whatever, so if I have a really big data frame, I can kind of inspect the bottom and the top and different parts of it at once. Another thing you're going to want to do, or these are basically just like attributes and methods that data frames make available. Another common one I'm going to use is shape, right? So you want to know the dimensions of your data frame. So they use an attribute called shape. Right, so this tells me I have 3 rows and 3 columns. Okay, cool. Now let's just come back to here. Let's look at, okay, so a couple other things I might want to do. Let's say something called describe. Describe. Cool. So describe is very, very helpful again when I have a big data set. Notice that the results themselves are returned as data frames, which is interesting, right? Like it's using the data frame object to even give results like this, even though right, this looks like just a descriptive table. But basically what a describe does is another thing that you're going to want to use on once I bring a data frame into Pandas. I'm like, okay, but I can't look at all the data by hand. Let me get some kind of descriptive statistics so I have a better understanding of what is what the data is in the data frame. So for one, it gives you a count. So this is the count of non-NA, like non-null rows in the column. So if one had let's actually just add that now. So let's just do, I'm going to add something. I'm going to add a null just so we can see. So I can use NP. NP has an NaN object, and that is basically a null. I might get some errors now. Let's see. Nope. So yeah, so here's our NaN, and when I added the NaN with the y, I still get an NaN, and when I square it, so there's my NaN still showing up. So this is like a null. So now if I rerun my df, let's do a describe again. Here, now you'll see some differences, right? So this has 3 non-null values. This has 3 non-null values. I'm just going to also print out my df so you guys can see it. Whereas this only has a 1. So this only has 1 non-null value. All right. Then this is the mean. So this is computing a mean over the non-null values, right? So the mean of column 0 is 10. The mean of column 1, even if there's only 1 value, because it's, remember, so this is dividing a mean. This is a really simple mean. It's 5 divided by 1, and you still get 5. And likewise 2 is the non-null values. Then it gives you a standard deviation, the min, the quartiles, and the max. So the quartiles are just like, I I know the general for quartiles is quantiles, and it's just saying what is the, it's like a 20% of the data are below X, and 20 or the you know, you've heard of the top 90% quartile. That's like gives you the numbers such that there are 10% of the data is above that, right? So the 50th quartile is also called the median. Okay, so this is a nice little descriptive table that we might want to use to describe the data before we start playing with it. Other really common things you're going to want to do are, so for example, so if I do df.columns, right, so this is just, so this is basically the default indexing. So the 0, 1, 2, this is just saying start. It starts at 0, it stops at 3, and by 3 it means like 3 it's a stop. It's not the, it doesn't actually include 3, and the step is 1. So this is just like, it's the default naming. But what I can do is pretty simple. I can just add a list, right? Maybe I want to call, I'm going to call it A, column B, and column C, or maybe like, you know, crazy, I don't know, come up with a name. I just save that out. If I even do this again, look, all of this has changed. I've set the columns now. I can do a similar operation here with the index. This right here is called an index. So if I do df.index, it'll grab me that stuff. I can again set those things. Let's call it Q, W, E. This won't change, but this will change. So this gives you a lot of flexibility here, right? So that's what this is. This is just an index. So if I just did df.index here, you'll see it's providing me all the names, just as an example of how that's being used. So right, so these are some of the just the basic building blocks. Once you pull your data into a data frame, you're gonna like set columns and set indices and things like that. Maybe one other thing. Actually, that's probably okay for now, honestly. Pandas, there's a whole lot of functionality around pandas. You're gonna get really, I'll do a tutorial just on pandas alone, and we'll really do a deep dive. A lot of good pandas tutorials on the web as well. But you know, I mean, suppose I just want to show you guys some of the documentation. But suppose I was like, you know, whatever, apply functions or something. Like I just search pandas Python apply function, and I'll just get the documentation. I have just seen this documentation so many times, and I know it backwards and forwards. You guys will as you continue to play with it, you'll start to know it backwards and forwards as well. It's an extensive library. And so you'll just look functions up, and you're like, cool, I just do DataFrames. So that's our df dot, you know, whatever we're trying to, you know, get it to use. Anyways, that's enough for the moment. Let's now look at Matplotlib. All right, so let's add a section for Matplotlib. Again, I'm going to change it to Markdown. Save that out. You see how nice this starts to look too? You know, I could even, you know, I'm going to add just as an example, so I can add more Markdown. I'm going to say simple exercises in Numpy. You know, I'm going to evaluate that. So it's really, you can start to add notes, all of that stuff. So it'll really keep your code nice, modular, really clean, really organized. In a typical data science project, you're going to have your imports, you're going to have your data acquisition section, you're going to have your data processing, cleaning, modeling, all that stuff. So that's kind of like what we're all working up towards. So that's why I'm laying it out like this. Anyways, back to Matplotlib. What does Matplotlib make available to us? Matplotlib is basically the simplest, most basic kind of Python plotting library. In data science, you're going to want to plot data all the time to really like start to, it's hard, looking at numbers alone is really hard to kind of get any good intuition for what the data is doing. But visualization is just like such a powerful thing. One line plot says a million words, what like, 1,000 data points, it's just, you'll never see it. So Matplotlib is very, very commonly used. So let's just do a simple plot in Matplotlib. Okay, cool. And I need some data to do that. Let's actually use our data frame data. So I'm going to use column A and column crazy. So one more thing. I guess I could have also said this in Pandas too. The way to grab your data is like this. So I'm going to say it's basically like slicing or like using a dictionary. So like you can think of the data frame like a dictionary object where the column name is the key. And if I say that, I'll grab that column. Additionally, I could say df dot a. This is like the slicing syntax, and this is the dot syntax, but it'll give me the same thing. Okay. Pandas and I'm gonna just use them both for now, just so we can see. So, but Pandas and Matplotlib play together really quite nicely. So imagine we wanted to do a really simple line graph that was a representation of this, of these two. Like I wanted to plot these two guys together. So remember, we saved it out as matplotlib.pyplot as plt. So this plt object is like our plotting guy, and suppose I want to do plt.plot, and I want to set, you have an x and a y, so let's just do df.a as our first data vector and df.crazy as our second vector. Oh, you know what? I forgot one more thing. Matplotlib or Jupyter doesn't plot inline. So this is just like a plot. So actually what this just printed out was like a plotting object. You actually have to specify to Jupyter that you want to actually have these plots show up inline. Another thing you could do is like write plots to JPEG files or whatever. But there's something in Jupyter Notebooks called a magic command. Sorry, there's a bunch of stuff coming at you guys right now. Jupyter magic commands. So maybe come and look at these at some point. Yeah, IPython Notebook might be one of the things that shows up, but there are these like things called magic commands. So I'm going to use one now. We can dive into those a little more later. But if I say matplotlib, I believe inline, I'm going to rerun that guy. Come all the way back down here, and if I do this again, there we have our plot. So it actually just plotted, the df crazy versus the dfa, and I'm able to look at that plot. Okay, so there's a whole lot to do with plotting. You can like set labels, axes, a bunch of stuff. I'm not going to go into all that now. There's other, there's just really so many different things that you can do with plotting. I just want to make sure you know that it's available. One of my gripes with Matplotlib is that it's really ugly. But I know I'm going to show you one other cool trick. Import Seaborn. Yeah. So you guys may not have Seaborn. If this gives you an error, well, let me show you what it does first. So I imported Seaborn. I believe I already have it. I can't remember if it's part of the Anaconda distribution or not. But if I go back and replot this, boom. So it makes it a bunch nicer. So Seaborn is just basically like, it's another plotting library, and it actually will clean up our Matplotlib plots for us, which is really nice. If you got an error here, what you want to do is come back to your terminal. Maybe open up another window or a tab, and just do pip install Seaborn. It'll install it, and then when you go back, you should be able to import it. All right. Okay, back to our notebook. But yeah, so here's the basics. So these are 3 things that you're going to use all the time in data science. You're not always going to be like creating your own data. Usually you're going to be getting data from the web somewhere, and then you're going to be manipulating it in Pandas, probably plotting it to get some understanding of what a column, how 2 columns relate to one another and things like that. But that's a lot for now. Let's call that the end of data science basics, and probably the next thing I'll do is either a deep dive into Pandas, and also we're going to start to play with some data acquisition, scraping it from the web. So check back for more videos on data science. All right, this was fun. See you guys next time. Bye.